Hi, so this is the first problem that I found. I have first of all to complete this tree diagram, right? So I have 3 over 4 here. So here I need to complete this with 1 over 4. 1 over 4 plus 3 over 4 makes 1, right? Then in the text it says that he will be late for work, and the probability if this happens is 1 over 8. So this is 1 over 8. And consequently, this is just a complementary, right? So 7 over 8. And then I will have the rest already filled up. In B, they ask, find the probability that Pablo leaves home before 7 and it's late for work. So these are two independent events, right? So point B, simply I have to multiply out waking up before 7, 3 over 4, times arriving late, so 1 over 8. So this will give me 3 divided by 32. Yeah. And I can maybe write it as a probability before 7 late. Okay. And then I have point C. Point C is telling me to calculate the probability that Pablo is late for work overall. So I have this solution and this solution. So automatically here I have to calculate the probability that is late, which is going to be 3 over 4. So if he wakes up before 7 times 1 over 8 plus the other branch, 1 over 4. So this one from 1 over 4 times 5 over 8. So this will give me a total of 8 over 32. 8 over 32, it's 1 over 4. Now, in point D, they ask us, given that the Pablo is late for work. So this given immediately should ring a bell about conditional probability, okay? Given that the Pablo is late for work, so the probability that given that it's late, find the probability that he left home before 7. Now here, we can use just the formula as we find it in the formula booklet. Check it out. So it's B intersected L divided the probability of L. So it's simply what we found above, 1 over 4, and the probability that it's leaving before 7 and that is late, right? It's going to be 3 over 4 times 1 over 8. So it's 3 over 32, right? So we will have equal this. This was 8 over 32. So we're going to have 3 over 8. Now we are at point E. Point E says that 2 days next week, Pablo will drive to work. Find the probability that he will be late at least once. So essentially, what we need to write down is the probability that it will be late at least one time, which includes that he's going to be late once, or that he can be late 2 times in a row. So in order to do this, you understand that somehow we have to construct a probability distribution, or at least this is useful. The outcome is, okay, that he's late. So it can be 0 time, 1 time, 2 time. And what's the probability? Well, the probability that he's not late, right? Let's read it from up here. So the probability that it's late is 1 over 4. The probability that it's not late is 3 over 4. So it means that 0 probability is going to be when he's not late the first time, 3 over 4, times the probability that he's not late the second time. While when we are trying to calculate the probability that is late once, it could be the first time, so 3 over 4, sorry, 1 over 4 times 3 over 4, plus the opposite. So we have that eventually he is late the first time, but is not late the second time. And then If he's late 2 times in a row, of course, this means that it's 1/4 times 1/4. Now notice that if we sum up these probabilities, we have 3 times 3 in the numerator, 9, plus 3, 12, plus 3, 15, plus 1, 16. 16/16. So the probability in total is what it should be, so equal to 1. So now the probability of him being late at least once is going to be late 1 time, so it's going to be 2 times 3/4 times 1/4, which is nothing else but this, plus the probability of being late twice in a row, so 1/4 times 4. So this is a 6 plus a 1, so 7/16. And this is the result.